Hey mathletes, in this lesson we're going to look at solving exponential functions. So remember, an exponential function is any function that has its independent variable as an exponent. So the good thing about math is that everything has an opposite. Everything has something that will undo it. It's called an inverse function. So this is the most basic kind. We've got some number times something that's raised to an exponent, and that equals something. So we know what to do if something's being multiplied. We're going to divide. So we're going to divide both sides by 75. That's going to cancel out. So 3 raised to the x is going to be 375 divided by 75, which happens just to be 5. Remember, an exponent is the number of times you multiply a number by itself to get something. So in this case, what it's saying is 3 times itself, x number of times, is 5. So since we know that 3 to the first power is 3, and 3 to the second power is 9, this is going to be a decimal 1 point something. So the opposite of an exponent is something called a log. So we're going to take the log of both sides because that is going to undo our exponent. So we're going to take the log of 3 raised to the x and the log of 5. Now since exponents are multiplication, what you really wind up with is x times the log of 3 equals the log of 5. Luckily, we know that the way to get rid of multiplication is to divide, so we're just going to divide both sides by the log of 3. In this case, the log of 5 divided by the log of 3 is going to be 1.649. They're going to tell you what number of decimals to give them. Usually it's the nearest tenth or hundredth. In this case, we're going to give them 2 decimal places. So we're going to call that 1.65. Just remember, exponents, the opposite of exponents are logs, but exponents mean the number of times you multiply something. So when you take a log of 3 to the x, you wind up with x times the log of 3. Again, this is all happening in your calculator. You're not figuring this out by hand. So in this case, one of the things we do with exponential functions is find out how much money we have. In this case, we know how much money we want to have. We just want to find out how long it's going to take to get there. So Owen invested $63,000 in an account that is giving him 6.5% compounded continuously. So we know we're going to use an exponential function with e in it. Remember Euler's number, 2.7128, goes on forever. So we just want to write our equation. We want to have $159,600. Evidently, that's how much money we need before we can do something fun like take a cruise around the world. So we're starting with P0 of $63,000 times E, because it's continuous, raised to an interest rate of 6.5%, so it's 0.065. We want to know how long that's going to take. Now the 6.5% is positive because we are earning interest. Something is going up. So the basic rules of solving an equation stand. This is 63,000 times E, so we're just going to divide by 63,000. So 159,600 divided by 63,000 is 2.5238. Again, when you're doing this, if you can't save the decimal in your calculator, you just want to leave good 3 or 4 decimal places. Now, since it is E, we're not just taking a log, we're taking a natural log. So on your calculator, that's the button that says LN. It stands for logarithm naturel. It's French. It's very fancy. So we're going to take the natural log of both sides. Now the nice thing about E, one of its many nice things, is when you take the natural log of E, it literally just cancels out. The natural log of E is 1. So which leaves us just 0.065 times t, so all we need to do is divide by 0.065. So before you're like, oh my god, this is a crazy number, again, you're just typing this into the calculator. I prefer to type it in as a fraction. ln of 2.5238 divided by 0.065 is just going to be 14.242. So 14.242 is a number of years. So since they want the nearest tenth, it's just going to be 14.2 years before Owen has $159,600. Remember, one of our kinds of exponential functions is periodic. It means it happens every once in a while. Every, say, in this case, 5 minutes, half of this element decays. That's why it's got a half-life. That's why this is 0.5. So it's decaying, so it's negative. So 1 minus 0.5 is why our growth factor is 0.5. It says we're starting with 700 grams. How long to the nearest tenth of a minute is going to take us to have 20 grams. So all we got to do is plug our numbers in the right spot. So we want to know how long it's going to be before it's 20 grams. That's our y value. We know we're starting with 700 grams. That's P0. 0.5 t divided by, in this case, 5 minutes. So again, since we're trying to isolate the t, we got to get rid of all this other stuff first. Good news is this is 700 times something, so we're just going to divide. So 20 divided by 700 is 0.0285 equals 0.5 raised to the t divided by 5. We don't want this 0.5, we just want t. Since it's an exponent, we know we're going to take a log. So we're going to take the log of both sides. So in this case, we're not actually going to find the decimal. We're just going to leave it as log 0.0285 equals t divided by 5 times the log of 0.5. Because remember, exponents mean the number of times you multiply something by itself. So when you take a log, whatever that was in the exponent is now multiplied by your log. So since this is multiplication, we're just going to divide again. So t divided by 5, once you type this into the calculator, again, I like typing it in as a fraction. So log 0.0285 over log 0.5 in the calculator, hit enter, you get 5.1328. So since this is just t divided by 5, we know the thing that undoes division is multiplication. Got to multiply both sides by 5. So in this case, the amount of time it's going to take to decay is 25.664 minutes. They want the nearest tenth of a minute. So we're going to draw a line here, past our tenth. The number on the right is a 6. So this is going to be 25.7 minutes. Again, you're just solving equations just like normal. Division undoes multiplication. Multiplication undoes division. Addition undoes subtraction, and logs undo exponents.